Right. Bonjour. Bonjour. Je m'appelle Petra Cross et je ne parle pas le français. Je parle l'anglais et slovaque. So which one do you want the talk to be in? Slovak? OK. Tak ma veľmi teší. Vítajte na tejto prednáške. Did anyone understand what I just said? No one, right? Okay, I'm going to speak in English. I'll try to talk in English. And we only have 55 minutes. I've given this talk 2 days ago. It took 65 minutes. So I'm going to fly through the slides, and I'm going to skip through some of the stuff. So we have some time for questions. So let me first introduce myself to you. For those in the back rows, this is what I look like. This is my email address. A little bit about my background. I studied computer science in Slovakia, where I'm from. Then I transferred to Santa Clara University in Santa Clara, California. Santa Clara is about 15 minutes from Google headquarters. After I graduated, I worked for a startup for a year. And after a year, I joined Google. And I've been with Google for 7 years now. I worked on search for 3.5 years. And then I transferred to Gmail. I've been on Gmail until January. And since January, I'm on Google Mobile Wallet, the NFC product. All right. This is me on the bicycle. I have a big bruise on my calf. Do you know why I'm showing you this statement up here? Do you know what it is? Do you recognize it? It's a Google mission. And Google's mission is to organize world information and make it universally accessible and useful. And any Googler should know this by heart. If you wake us up, or any Googler, if you wake them up at 2 a.m., they will know it, and they will say it. It's something that they keep repeating to us all the time, because anything we do, we are trying to do to achieve this goal. And so that's the reason why I'm showing you the slide. It's always nice to step back and think like, what are we really trying to accomplish? And then I'm going to talk about how we're trying to accomplish the goal. But first, so what did I come here to talk about? By the way, this is the view from my desk in Google San Francisco. I just figured out I have to rub it in. This is the agenda. We're going to talk about, is it me or is this thing shaking? We are going to, am I shaking it or someone else is in the back? Yeah. I'm going to talk about teams and roles, the structure of engineering teams at Google in different engineering offices around the world. Then I'm going to briefly talk about the development workflows that are used in the industry in general. And I'm going to hopefully spend most of my talk talking about the specifics, what Google does to be productive and develop software faster. Google is really big. We all know that, right? To be specific, we have more than 10,000 developers. We have more than 30,000 employees, but we have more than 10,000 developers, software engineers. And they work in 40 different offices. We have about 20 people checking code every single minute of a day. It's a lot of code. And 50% of our code base changes every month. So you can see a potential for pretty huge chaos. And I'm going to talk about how we organize this chaos. This is the busiest slide of the presentation, so I apologize ahead of time. I'd like to show you the hierarchy we have in the engineering department. Of course, it starts with the CEO, Larry Page, and then there would be some level of a senior VPs, and then there will be vice president. For example, there would be one vice president for the area. There would be one vice president for search, another vice president for social, another vice president for Chrome and apps. So just to give you an idea, Gmail, for example, it belongs into apps. So there's Google Docs and spreadsheets and calendar. And Chrome is part of apps and Chrome. And we all share the same VP. Then the vice president would then be managing different engineering directors. And each engineering director is responsible for one product. So we have one engineering director in Gmail, for example, or in payments. Engineering director, we all know what that is. Then product management, we all know what product management is, right? Yes, I don't need to explain. These are the people who try to represent the users, who hopefully know what the users want, and who can tell the engineers what the users need. Then we have engineering managers, which can also be called project manager. When we say PM, we mean product manager, not project manager. The engineering managers, we just call them managers. And they manage resources, they manage engineers. We would have about 20 engineers or 30 engineers being managed by a single engineering manager. And now let's talk about the actual people who write code. All of these roles are listed below the engineering manager. So SWEs, we call it SWE. It means software engineer. Software engineer or programmer or developer, we call it software engineer. I know in Europe you call it programmer, right? These people write code most of the day, but they can sometimes also be leading a smaller group of people. That's what the TL means. TL means tech lead. When I was on Gmail, I was working with a small group of people, and I was the tech lead of the team. So tech lead is not a manager. Tech lead is a software engineer that has additional role of leading the team technologically and being the go-to person for questions, mentoring people on the team, being the API between your team and some other team, basically going to more meetings than anyone else. It kind of sucks, and you also have to be productive. You also have to write code in addition to going to all those meetings and going through design reviews and things like that. Sometimes the tech lead will also be a manager, but it's rare, and that will be TLM, tech lead manager, and that means that you are a software engineer, tech lead, and a manager. That's a lot of hats to wear. SET is a software engineer in test. These are regular engineers that are coding, but they're not coding a product. They are writing testing frameworks. So their code never runs in production, but their code is used to test and is used during release of the products. TE is test engineer. TE does not write codes. TE, well, maybe sometimes. TE writes test cases, specific tests that use the framework that the SET wrote. Does it make sense? And of course, we have manual QA, mostly in India. We have also some in Mountain View. And many other testing roles, which I'm not aware of because I'm not in that environment. So this is a hierarchy example. You have VP of engineering that manages the director of engineering that manages a handful of engineering managers. One of the managers would have 10 to 30 people. They're all SWEs, except some of them might be TLs. This guy is a TLM that manages 2 more SWEs. And that SWE over there has an intern. That's like a typical thing. So you can have an intern, which you technically manage, but you're not really a manager. Does it make sense? This doesn't look good, but it's supposed to be circled in the center. This is the subset that would be considered to be a team. So this would be a group, for example, Gmail frontend. It would have 30 people or so. I'm not saying that that's the number that we have, but just an example. And this would be one of the teams. For example, the team that's trying to do Google Plus integration into Gmail, or the team that's changing the UI to change it to the new look. The teams are created based on need. It's not like this little team exists forever. When Google Plus came up, we had to change the look of Gmail, and so the manager would reshuffle people to different groups. They would just group them differently, and this new team was created for changing the look of Gmail. Now that the look is changed, this team was dissolved, and the people are now, for example, working on Google Plus integration, or we have a monetizing team. These teams are usually 4 to 5 people big. This is what it looked like when I joined Gmail, when I transferred to Gmail from Search in 2008. I call this room a dungeon. It was the darkest building I've ever worked in. And this is just an example of what the environment looks like when it's really crowded. Everyone gets 2 monitors, 24-inch monitors, or 130-inch monitors, except for Greg over there. He snatched 2 more monitors somewhere. I don't know where he got them from. You can decorate in any way you want. You can see some IKEA stuff over there. People have laptops, all kinds of ergonomic mice and keyboards. But the idea is that you don't have your own room, your own office. Everyone is in this big space. We call it mega cubes. It has a cubicle wall around it, but it's really a mega cube because it has like 20 people in it. And if you like quiet, Google is not a good place for you. You can use headphones to signal to people that you don't want to be disturbed, but everything's fair. If you don't have headphones, don't complain. People tend to sit together, clumped by team. So 4 or 5 people would sit around like a little pedal-like shaped collection of tables. Then we moved to, actually, this is my dog. I had to show it to you. Her name is Fluffy. And this is the building we moved to after we moved out of the dungeon. It's a building 2000, the same building where Google Store is located. And same idea, giant mega cube. There's some gate for the dog. Someone has a dog over there. The balloons are for the new Googler, new engineers that come, they get the balloon. And machines everywhere, boxes, because we move all the time. I moved like 11 times already for the last 7 years. And this is my new desk in Google San Francisco. I transferred in January. It's right on Embarcadero by the bridge, by the Bay Bridge. Okay, so I showed you all these beautiful spaces and the nice view, but what are we really trying to do at Google? Did anyone pay attention earlier today? What are we trying to do? Organize world's information. Anyone? No one's listening. And how? What do you think? How do you do that? Ideas? We write software? Does it come as a surprise? And make money? And so here is what you're all familiar with. This is what a software development looks like on a timeline. You start with an idea. It comes from a user, it comes from anyone. Engineers can have an idea. But usually it would come, somehow it would get to us, engineers, from the PM, the product manager. The product manager comes in and tells us, you have to do prioritized email, prioritized inbox on top of the rest of the inbox. That's an idea. Then it would be written down in well-described features, feature requests. Then they would be planned in certain order, right? Then they will be worked on, developers will be working on all these features. Once the feature is written and tested, we write our own tests. We don't have testers to write our own tests. I'm talking about unit tests, like JUnit. Once we have the production code and the unit tests, we send this whole piece of code, we call it change list of changes, right? We send the change list for code review to another Googler. I know that not many companies do that, but it's required at Google that at least 2 people look at every change that goes into the code repository. During code review, you learn a lot of new things because the other person tells you what you're doing wrong or what you can do more efficiently. During code reviews, you hear things like, add a test. That's like the most common thing that you hear when you send a change for code review. And so by the time you get an approval from the code reviewer, you're pretty confident that your change is not going to break things. I mean, it can break things, obviously, but you're less likely to break things because more people verified your code. Testing, it should happen before code review. But it goes through, after it gets checked in, it goes into continuous build, right? And continuous build runs all the tests constantly, continuously. At some point, now this depends on the product. It can be every day, it can be every 2 weeks, but somewhere in that range. A release engineer or some script, more likely it will be automated by now, would pick up the state of all the code in code repository at the time when all tests passed in the continuous build. We call it a CL, change list. And then they cut it. They cut it at the change list. They cut the release at the given change list. So it means that everything that got into the code repository before this change list is in. It will be deployed in the binary. And everything that got in after will not be in. So they cut a change. They cut the build. They build a binary. They will run it somewhere for a few days. For Googlers use it internally. For example, my Gmail that I use, my corporate Gmail, it has all the newest features that were checked in like yesterday. We call it dog fooding. We dog food our own. It's like eating your own dog food. It's kind of weird, but someone came up with that name. So we test our own things, and we have to live with the breakages and report them. Once it's there for a couple of days, then it gets approved to be pushed to production. The production push first starts by going to Canary. Canary tends to be just a handful of machines, or it can be, depends on the product, it can be 1% of all users. It's just like a small subset of all users that will see that new version of something, of Gmail or so. It's there for about 2 days. People that are on the testing team are watching the latency metrics. They look at numbers like, did Gmail's load time get worse or get better, right? You don't want to have it slower. It's already slow as it is, right? And if it's stable for 2 days, for 2 peaks, and you have 2 peak hours, then it gets pushed 100%. Features are pushed by turning on a flag. So by the time someone enables a feature on Gmail, it's been in the binary. It might have been there for a month. And that gives us the flexibility to turn on a new feature from a date, from a minute to a minute, and then correlate that with a big PR release or something. And this is what we're trying to do. Make it shorter, you see? It took a long time, now it takes half the time. Now how can you develop fast? You can either drink a lot of coffee, right? Stay up all night. Or you just work on what really needs to be done, and you focus. You need to be really highly focused on what needs to be done. We want to maximize the return on investment on the developer time, get the most out of our developers, basically. So how do you do that? You can either throw more people on the problem, or you can make people more effective. What do you think makes more sense? The second, yeah. Okay, so we're going to reduce the waste. I'm going to fly through this. This just shows you what happens every single year in America. The amount of wasted money on projects that, now by the way, billion is milliard, right, in French. This only includes the projects that fail, like 100% fail. It doesn't include projects that get delivered late or that go over the budget. This is a busy slide. I just want to point out that the state of California, sweet home, wasted $44 million on a system for DMV, Department of Motor Vehicles, where you get your driver's license. And this happens all the time in all the companies. So now let's talk about, we're going to the second part of the talk, when I'm going to talk about the development workflows, before I move on to the Google development workflow. There are 3 that are most known. You must have seen at least one of them. The waterfall, the spiral, and the agile. The waterfall is old school. In the car industry, car manufacturing industry, they need to define the requirements before they can design a car, before they build a car, right? You're not going to build a car and then decide it should be 5 centimeters wider. So it makes sense, if you're dealing with tangible products, it makes total sense to to have all the requirements up front and then move on to the design. And once that's done, then move on to the production. This whole thing will take maybe years, definitely many months. It's not very good for software, but at first it was actually used for software. And I found out on Monday that there's still some software companies that do this. Do you know what kind of software they develop? Nuclear power plant software. God have mercy. Okay. Spiral. Spiral is the next step from the waterfall. You can think of it as a sequence of waterfalls, one waterfall after another. And each waterfall will yield a version or a prototype of the product. So you would start by making the first prototype. It takes like 6 months. One whole spiral, one 360 in a spiral will take you about 6 months. Did I just hear a dog bark? It was not a dog. Someone was coughing. It sounded like a puppy. I love dogs, so I'm always like on the watch. So you would do 6 months, and then you would end up with the first prototype, which might or might not be what the customer wants. If it's not what the customer wants, you just wasted 6 months. Well, you need to change the requirements and do another 6 months. And each iteration is 6 months long. So you are kind of flexible, but it's like you're driving a boat, but you can change, you can adjust the steering wheel only every 6 months. So you're going like zigzag, right? We want to go straight line, so you're not wasting any time and money. And Agile comes to the rescue. Agile is a very sensitive word that many people react to very differently. There are people who hate the word. It's very religious. Some people just can't even stand hearing it. Some people are absolutely into it. So at Google, we have this guy who teaches Agile to different engineering teams. He does not use the word Agile because he does not want people to start already getting negative about it. He calls it estimation and planning. But it's all about just the practices. Call it whatever you want to call it. The idea is that you collaborate with your customers constantly. You get frequent feedback. You are working in very collaborative small environments, and you're iterating very, very fast every week or every 2 weeks. It's like you're steering the wheel, but you're adjusting every week. It's better, right, than every 6 months. And you can also release every week or every 2 at the end of every iteration. So I'm going to dive into it. But before I do, there is 3 more terms or buzzwords that you probably heard. Extreme programming, Scrum, and Kanban. And I know that there are some experts on some of these, so I'm going to give my best shot trying to tell you what the difference is. The extreme programming is mostly known for its heavy use of promiscuous pairing, when you're supposed to pair with a different person every day, and that way you will learn everything from all your coworkers when you're pairing with different coworkers every day. Scrum is agile, but it's for PMs, product managers. So we don't really do Scrum at Google. Maybe some PMs do, but I don't know anyone that actually does it. But we do agile in the engineering teams. But if a PM decides to do Scrum, they can totally do that, because that's how they would be managing the agile teams. And Kanban is, if we have any Japanese in the room, I think they would agree that Kanban means board or whiteboard or something like that in Japanese. The idea is that you would have some card. This is an example from Toyota. And the car, in the car manufacturing, this card would be traveling with every part. So you would have a door, car door or something, and it comes with the card that tells you where it came from, where it's now, where it's supposed to go next. So you just need to look at the car, you know exactly where in the system this thing is and what this thing is. And similarly, you do this with software engineering tasks. You write a task on the card. You clearly define what the task is. You give it an estimate, how long it should take, in terms of points, not in terms of time. And then you give it an owner, if it has an owner, you know who's working on it, and a state, you know whether it's in progress, or whether it's in code review, or whether it's checked in, or whether it's pushed to production, or what's happening with the task. So what do you think Google does out of all these that I just mentioned? We have waterfall, spiral, agile, all of these buzzwords. Waterfall? Nice guess. Someone's been paying attention. We do everything, but we call it agile, or we call it estimation and planning, for those who don't like the word agile. So if you go to Google and type in 10 things, just 2 words, 10 things, this is going to be the first result, 10 things that Google found to be true. And the first thing is that if you focus on the user, everything else will follow. And it's similar to our mission. Everyone knows this statement. And in this fashion, we also work. So we start with the user, who represents users, PM, the product manager. The product manager / user would come to us, and then they would tell us what the story is, what the user wants. For example, an ATM user wants to view their balance when they go to ATM. How do you say ATM in French? I know it's a crazy long word, and can you say it out loud so everyone knows? Okay, doesn't everyone know what ATM is now? Okay, good. So I'm going to be using the word ATM from now on. As an ATM user, you want to see your balance. That's a user story. As a district manager, you want to view all the ATM usage in San Francisco. That's another user story. So it's like a feature or a part of a feature. But if you give this to an engineer, they'll be like, they will be thinking how to do this. There's many ways to achieve this. That's not a task. Task is something you know how to do. This is something that you need to think about to know how to do. And that's why we don't work from user stories. We don't work on user stories. We work on tasks. By the time it gets to an engineer, a story would be broken down into 5, 10, 20 tasks that can be done by 5, 10, 20 people. And I'm going to show you in the next slide how we actually break down the stories. A task is clear. It tells you what to do. It doesn't tell you how. You can do it any way you want, but usually there's only 1 or 2 good ways to do it, so it's clear. And it has a clear description. You know exactly what you need to achieve, and it needs to have a stopping condition, or is it called stopping condition? Acceptance test, which means when, let's, for example, acceptance test for a user story. For as an ATM user, I want to view my balance. Even if the balance looks really ugly in some Courier font or something, you're done. The PM cannot be like, oh, but it's supposed to be nice and it's supposed to have these animations. No, you didn't ask for animations. Does the user see the balance? Yes, I'm done. That's the acceptance test. We don't do anything more than is absolutely, that's written and absolutely required in the description. Whatever's not in the description, I'm not going to do. And this really forces the PMs to be really accurate and precise in writing their user stories. Because if they don't write it, we're not going to do it. We don't presume anything. All right, so let's see how we would break down an example user story. ATM user wants to view their balance. This is just a really trivial, kind of rough breakdown. There will be a lot more than 3 tasks if you break that down. But roughly, you need to define some API between the ATM and the bank, right? So they can communicate. Then you need to implement the bank side of the API, some servlet somewhere that's going to access data in a database and add numbers up to get the total, or maybe just call some other server that already knows the total. I don't know. That's the back-end work. And then the third task will be the front-end work, the thing that the user would see, well, both the UI and the front-end server that would, I don't know, display this, populate some JavaScript, HTML structure. So that's 3 different tasks. And you can clearly break it down even more into more tasks, right? Now, I was telling you about the Kanban card, that each card has its own state. So the car part could be in different states, and I don't know what the states of a car part may be, so I'm not going to try to give you examples in the car industry, but in a task world, in an engineering software task, you would have these different states. A task is either in the icebox. Icebox is like a freezer. It's there, it's chilling, no one's working on it. It might or might not be worked on in the future. Most of the stuff from the icebox will never get done. In fact, we clean out the icebox all the time, because people come to you all the time asking for stuff. You just write it on a card or put it in a spreadsheet, wherever you keep your system, and tell the people, okay, I wrote it down, it's in the icebox. We're going to prioritize it later, which might never happen, but you just keep all the things that you ever might want to do in the icebox so that you don't forget. Then you have backlog. Okay, so let's go. This is the icebox. I have a nice photo of the ice. Backlog. Backlog is something you're planning to work on. Like here, this guy is going to drink all these beers from right to left. And backlog is the most important list that you have on a team. Backlog is the number one thing that you need to be paying attention to if you're on an agile team. It's very short. It only has tasks for one iteration. So if your iteration is 1 week long, you only have 1 week, maybe 1.5 weeks worth of tasks so that you don't run out. You want to have there enough tasks so that you have enough tasks for one iteration. If you have a 2-week iteration, then you will have 2 weeks worth of tasks in there, maybe 2.5 weeks, just in case. And it's prioritized. So whatever's in the backlog you're going to work on in the order it's listed on the backlog. And backlog is something that everyone's looking at. Every person, manager looks at the backlog, developers look at the backlog, and also PMs look at the backlog. Developers look at the backlog to know which task to pick next. All they do, they just look at it's usually in a spreadsheet or maybe on a whiteboard. And then you pick the first task from the top that does not have a name next to it already. And then you put your name next to it. You might have a column for, name who owns the task. Once your name is on it, the task is yours, you're working on it. You can change the state to in progress. It's not in backlog, it's in progress now. And when you're done, you just mark it as done. And so manager does not need to come to you and ask for status update, because all they have to do is look at the backlog. You might have 2-3 tasks that you're working on at the same time. And the manager can quickly see at like a simple glance, they can just see who is working on what without having to ask anyone. So doing stand-ups, it's something we don't really do. Some teams do, but we don't really recommend, because stand-up is a meeting when you just say what you've done yesterday, what you're going to do today, and what you're doing now. Why would you need to do that? Why do you need to say it to anyone if it's written in the backlog? You know what you're doing next. It's the next thing that's not taken, that's in the backlog. Everyone knows what you're doing now. It's the thing that has your name next to it, and the status is in progress. And everyone knows what you've done. It's the thing that has your name next to it, and the status is done. So it saves a lot of meeting time. You don't have to do stand-ups every single day. So backlog is prioritized. And then when you're working on something, you just change the state to current or working on. Here, my coworker Emil is drinking beers. And notice he accepted all of these. He put his name next to them. Well, these are beers, but if they were tasks, there will be his name next to them, so no one else can grab them. And this is when you're done. This is actually a picture from a pub in Prague downtown. Each row is a different table at the pub, and there is a tap at every table, and you're competing with other tables who drinks more beer. But you see, they keep track. Just like in Agile, they keep track of how much they've done. So in Agile, you would just change the task to done. And it's verified and tested and submitted. This is an example of an analog version of the system. Some people do this in a spreadsheet, some people do this on a whiteboard. If you have people in the room, if they are not in like other offices, but all in one office, you can use whiteboard. We call these things, each column, we call it swim lanes, because it's like the swim lanes in the swimming pool. And tasks of one state are in one swim lane. So the left swim lane is backlog, or scheduled. They call it scheduled, backlog. Icebox is never on this thing. Icebox is like on the side. You don't look at Icebox. You only look at the backlog. So when you're ready to start working on something, which task are you going to take? The one on the left and from the top. You take it, you put it into the second swim lane, and you put your name next to it. Notice there's faces next to people's next to these tasks. And some of these have two faces. It seems like this team is pair programming. But some teams don't pair program, and that's fine. And so this means that it's being worked on by these people. Once you are done, then you move it into done. They call it checked in. It's checked into code repository. And for some reason, they have also another swim lane for QA. Maybe they have another stage QA. We don't do QA. We don't have a state for QA in my team. So this is just a recap of what was on the previous slide. There was the backlog, the current, the working on. In review, they added another state in review. I don't know why. It works for them, that's fine. Checked in, which means done, in QA, and then they have done. Okay, so what our team considers as done, they have in 3 different states: checked in QA, and done. Does anyone remember what I just said? There's a lot of them, huh? But what are the most important ones? Icebox, just a pile of stuff that might or might not get done. But the most important one is called what? Backlog, right? Or scheduled. And how many tasks would it contain? Just enough for 1, maybe 1.5 iterations so that you don't run out. And what's most important about backlog? What's the important property of backlog? It's prioritized, it's ordered, and you always pick from the top, yes. And it's actually really good to have these iterations, these 1-week iterations, because no one can come and tell you to do something else. You know exactly what you're doing this week. If someone wants you to do something else, it's going to be done next iteration. You put it in a backlog for next iteration. So you don't need to be changing priorities in the middle of iteration. Obviously, if there is some fire and like Gmail is down or something, you're going to fix it. But if it's something that can be done next week, you're just going to put it into next iteration. How do these tasks end up on the whiteboard? This is going to be interesting. This is the worst case scenario schedule, calendar of this is a tech lead's calendar. And this is really worst case. This team is doing stand-ups, which I discourage, but it's there just for an example. And then the tech lead and the PM would meet a day before the planning meeting for pre-planning. You don't need to meet with them. You just do your pre-planning and maybe send an IM to the PM to ask if you have any questions. But you can also meet. But you just basically need to put some time aside to plan, put the tasks in the backlog before the meeting, before the planning meeting. Because on the planning meeting, you are only estimating. You are not putting things in the backlog. You're only estimating what's in the backlog. So a day before the beginning of the next iteration, you would write a list of tasks for this next iteration. And then you work with PM to make sure that it's in the right priority. And it's what the PM would want you to do. And on the day off, you might have a demo. We don't do demo. I don't know what's there. You might have a retrospective. We do it only once a quarter. We don't do a retrospective every week. And then you do a planning meeting. But our team can do it in 20 minutes. It took 1 hour at first when we were just learning how to do it. Now it takes 20 minutes. There's more pictures just to keep you from sleeping. This is an example planning meeting. I believe this is in Google Stockholm. And all you do, you just look at this backlog that has 20 items, for example. and you go from the top to the bottom. You just read the item out loud, and everyone estimates the item. And I'm going to show you how. We already know the backlog is ordered by priority, and you estimate as you go, so from the top to bottom. And you estimate in terms of points. Now, let me tell you what the point is. Point is something else for every team. It's always something different. A point might be an hour for that team. It might be a day for another team. But you never say how long it takes. Because as soon as you tell someone that a point is half a day, they will start being really inaccurate at estimating. Turns out that people are really good at telling you how hard things are, but they're not really good at telling you how long things take. So if you ask me how long it will take to write, I don't know, a unit test, I'll tell you 2 hours. And 2 days later, I'll be still writing it. Because something went wrong, and I didn't plan, and I didn't know it's going to be harder than it was. But if you ask me, is this unit test harder to write than that unit test, I'll be able to tell you a lot more accurately to compare it to something that I already knew how hard it was. Does it make sense? So you never say time, you never say any mention of hours, days, minutes, nothing, just points. And this is what it looks like. You are at the meeting, and you have a list of 10 things. If you have a short iteration, you might have 10 tasks. You read the first task out loud, like make a schema change to MySQL schema, add column so-and-so and a foreign key so-and-so, right? That will be a task. And whoever facilitates the meeting will tell everyone to start voting. If you're ready to vote, you lift a card, or you can just use your hand. So you lift your hand, and on the count to 3, everyone shows the number. So you would go 1, 2, 3. Then you look around, and you would have 4 or 5 people in the room. You would be like 2, 2, 2, 2, 5. Okay, so most people agree that it's a 2 points. This person thinks it's a 5 point. So you start by selecting one person with the lowest score. So a person with the 2 points would say, to do this task, you have to change file so-and-so, and that's all you have to do. Then you look at the person with the highest score, and they have to say, to do this task, you have to do that, plus you have to do this, 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 and that. So did you notice that none of these people said things like, oh, it's easy or it's hard? No. You cannot say any emotional, any kind of judgment. You don't judge the task. All you are allowed to say is, to do this task, one has to do A, B, and C. There's no feelings, emotions, judgment involved in this. And how do we know what's a 2-point task? And how do we know what's a 5-point task? Because the team at the very beginning, very beginning, when the team started doing Agile, we all agreed that something is 2 points and something is 5 points. We just set the standard. We showed 2 example tasks that we've done in the past, and everyone agreed this is going to be 5 points, this is going to be 2 points, and this is 2 to 3 times harder, so it's going to be 5 points. And now everything we estimate, we compare to these 2 tasks, the 2-pointer and 5-pointer. So if I'm voting 3 points, it's because I think that this new task is slightly harder than the 2-point task that I already knew that was a 2-point task. If I'm voting 8 points, I know it's harder than the 5-point task that we all agree was a 5-point task. So you go through this, and you have these disagreements. Like if you have an outlier, 5, then you let the person speak and say what it takes to do the task. You revote. Turns out you revote the second time or third time, most people are going to match. It's going to be 2, 2, 2, 2, 2, or 3, 3, 3, 3, 3. If you have outlier that's just like that, like 2, 2, 3, you just round it down to 2. If you have 2, 3, 3, you round it up to 3. And you don't discuss how you're going to do it. If everyone agrees, if you have 2, 2, 2, 2, 2, 3, you just mark it as 2 and you go to the next task. It doesn't matter whether people want to do it in a different ways. It doesn't matter how they plan to do it. As long as they think it's a 2 points, that's all that matters. So you go through these tasks really fast. In 15, 20 minutes, you are done, and meeting's over, and you can just spend a whole week or 2, depending on the how long your iteration is, just coding and having no meetings at all. So remember this, you have to follow a specific formula. We have to say, to do this task, one has to do blah, blah, blah. It sounds like you're a robot because you have to speak like that. You're allowed to ask a question. Sometimes you don't know how to vote. Then you lift a question mark, or do this, I do this as a question mark. When you have a question mark, let's say we have 5 people in the room, and it's going to be 2, 2, 2, 5, question mark. So we start by having someone with the 2, with the lowest number, to tell us, to do this task, you have to do A, B, and C. Then we look at the person with the highest score, the 5-point person. They will do the same. They explain what it takes. And then we look at the person with the question, and we ask, did this answer your question? And if it says yes, then we revote. If they say no, they're allowed to ask a question in a binary format. They can ask you yes, no question, or they can ask you a question that they give you 2 choices. You cannot just ask, how are you going to do this? No. You are going to ask specific question. You can say, does this change include writing a client for blah, blah, blah? And the answer is yes or no. So again, very quick. You get answers really quickly. There's no open discussion. You do this with your coworker, one-on-one. You don't do this in a team meeting when everyone's sitting there and waiting for you to have a discussion. No. So this meeting is really quick. And we already know that you always pick from the top. You pick the task from the top, whether you know it or not, whether you like it or not. If you don't know how to do the task, that's fine. You just pick it anyways, and you ask questions. Or you pair program with a coworker, and the next time you do similar task, you'll know how to do it, and you can teach someone else. We do not want to have islands of knowledge. We don't want to have this one guy who knows everything, and he goes on vacation, and we're screwed. So it's very important that you pollinate, you have cross-pollination of knowledge. You spread the knowledge as much as you can. You can pair program and learn this way, or you can just ask questions if you're stuck. And spend more time on it. Read a tutorial. Like you've never done a MySQL schema change? Well, go and learn MySQL 101 or tutorial online. It might take you 2 more days, but you will learn a new skill. And it's okay. Even though it's a 2-point task, it took you longer, it's fine, because it will all average out. A 2-point task that took you longer than 2 points, that's fine, because someone might start working on a 5-point task, and it will take them less time to do a 5-point task. It will average out. So you will know what is the pace, we call it velocity of the team. At the end of the iteration, we count all the points that were finished in that iteration. That's the total. So you might have a velocity of 15 points per iteration. And you can graph it, right? And you can smooth it out. You can make like a 3-week moving average of velocity, and you'll clearly see how many points it takes you to do a task, how quickly you progress. So when a PM comes to you and asks you to do this feature by the end of the quarter, you can figure out, you can break it down. Not in the office. That's right. I'm right here. I'm still working, though. If a PM asks you to do something, some big feature by the end of the quarter, you can say whether you can do it or not, because you look at the feature, you break it down into tasks, and you know this is 60 tasks. My team moves 12 tasks, does 12 tasks every iteration. That's 5 iterations. The quarter ends in 2 iterations. There's no way we can do this by the end of the quarter. And this is very valuable. But that's not the main reason why we estimate. The number one reason why we estimate is not to just be able to say no to people and to be able to know how quickly we can get things done. Do you guys know what's the main reason why we estimate? To understand, what has to be done. To drive the requirements. So, because you might write a task and then people disagree. Someone gives you 1 point, someone else thinks it's a 5 points. It doesn't mean that they don't know how to estimate. It just means that they don't understand what the task is supposed to be doing, what's the requirement. And that's why we go through the exercise of estimating so that we rewrite the task. Once the person with the 5 points explains that, why it's a 5 point and tells you what all the different things need to be done to achieve this task, whoever is taking notes will rephrase the task to make it clear that it includes this, and that. And it's really useful. And when you're estimating, you learn a lot about what you don't know. Because your coworkers who know more about it, they might be estimating with higher or lower points, and then they will be telling you why. And you're going to learn from them. Because they will explain what needs to be done to do this task. And you're like, oh, I didn't know. But you just think it to yourself. So you are not embarrassed in front of people. But you will realize, oh, I need to learn more about this area or that area. It kind of makes you aware of what you know and what you don't know when you listen to people during estimation planning. Daily stand-up, discouraged, highly discouraged, because it takes too much time. Why would you need to go to stand-up if everything is on the whiteboard? Just look at the whiteboard, it's right there. Waste of time. Retrospective. You familiar with retrospective, are you? It's a meeting where you come, everyone gets 3 cards and a pen. They write what went well on 1 card. They write what did not go well on another card. And they write specific suggestions on the 3rd card. So for example, the first card will be what went well. I really like this new system. I like that we do not have stand-ups anymore. That might be the good thing, right? Another card will be the negative card. For example, you can complain, the code reviews take too long, or code reviewers are not responsive, or anything that you did not like or didn't go well this iteration, or since last meeting. And the 3rd card is specific suggestions that you have to change the system. Add a new swim lane, or new state, or change iterations from 1 week to 2 weeks. Any kind of suggestions that will make the system more effective and better for everyone. And this is my last slide, and I have 4 minutes for Q&A. This is a picture from Google Venice last month. I took it there last month. They have this nice hallway with doodles in there. All right. Question? Okay, we're talking about refactorings and what? Technical debt. Okay, so how do we plan technical debts and refactoring? We add it to the backlog. So backlog contains tasks that come from user stories, but we also throw in tasks that are technical debt and refactoring. And the PM just needs to accept it. We're going to tell the PM, we have to refactor this in order to do your task. So we have to do this first. Yeah, it just goes in. It's a regular task. Even me speaking here is my task. I should have it in my spreadsheet. There was a lady. Yeah, go ahead. No, not necessarily. The tasks doesn't. The question was that it means that when I start working on a task, I already should know which part of the code will be accepted and what needs to be done. Not necessarily. If someone tells you, write a nice UI to show, I don't know, a countdown to the New Year's Eve, you can do this in JavaScript. You can use Git. You can use any way you want to do it. There's many ways you can do one task. There's many ways you can implement the backend. There's many ways you can define an API. The task is what's the result? The result will be that something will be on the screen. But how you're going to achieve it, it's up to you. But obviously, you should use what your team is already using, reuse all the technology you already have, all the frameworks you already have in place. You're not going to bring in a brand new language, programming language, just because you want to do a task in a different language. But you can do it in pretty much any way you want that is the fastest and most efficient to achieve the goal. Did it answer your question? No? Oh, when you discover a problem, yes. Yes, when a new problem, you discover a new problem in the middle of iteration, you're going to add it there as a task. You don't give it any points. So just keep it there so that you know that you're working on that. Add your name to it and say, this unexpected refactoring, your name. Don't give it any points. There will always be like a certain percentage of tasks that you work on that were never planned, and it's okay, because your velocity will always, it will be averaged over time. Yeah. Are we out of time, but can we continue talking, or who knows? Okay, I'm going to continue. Question?
How, who, and when do you write user stories down into tasks?
Okay, when they're done during the pre-planning meeting, or you don't have to have a meeting with the PM. The tech lead should be doing it. Usually tech lead does it before the meeting. But when I was a tech lead on Gmail, I did not like to do it all by myself because it felt like the rest of the team didn't really pay attention. So what I did, I started a rotation. And so every iteration, a different engineer had to do this. And they actually learned how to do it. And everyone got better at it. So it's up to you how you do it. One more? Done? Okay.